So this is the hydraulics, the pontoon, the pilots, the other pontoon, the bucket to let out the garbage, the bucket, the string, the syringes and the water inside, the tube,
So that's how it all works with the little string there. And that's it. So for our project, this is a little demonstration of the Big Blue. So right now, Bailey and Justine are making the current. And the way that this thing will work in the current, if the current is too strong for this thing to manipulate around in, it'll sit in one spot and it'll catch all of the stuff in the bucket, and then it'll bring the bucket up. Or if the current isn't too strong, where it can actually move around, it'll go up and it'll actually pick up the garbage and everything it needs to pick up. So as you can see, the Big Blue can also float with a large amount of weight, and it can always still take a bit more. So that's as much as the Big Blue would hold, maybe, until it started to, the deck started to fill with water and the garbage floated away.
Okay, so I'm going to talk about the hydraulics on the Big Blue. So the hydraulics are, they consist of the syringes, the water, the string, and the bucket. So when the syringe is pulled back, the bucket lifts up and puts all the garbage onto the deck. And when you push it back down, it goes under the water because any suspended items in the water. And when you pull it back again, it'll put them all up through the bucket and then onto the deck where we can later take them off and dispose of them.
So how the Big Blue floats, it's on these floaties, which are less dense than the water. And less dense, I mean there is air particles in the pontoons, and they're less dense than the water.
So our product is called the Big Blue, and our slogan is "Be clean for a better future." So first of all, we will describe our fluid properties. So our fluid properties on the Big Blue consist of the water in the syringes. In the syringe, the water is more dense than in the top of the syringe, where the water is forced out and makes the bucket move. The water is pushed through the syringe, and when the pressure is so high that the water pushes the syringe back and makes the bucket lift. For example,
The viscosity on the Big Blue is the water in the syringes, and the water in like how it sits in them. And since it isn't very viscous, that's how it flows through freely.
So the density part of the Big Blue, the density of the Big Blue is how the Big Blue is able to float on top of the water because the pontoons is less dense than the water. Say if you took the strip of the pontoon, filled it with water, and had another one with air, the one filled with water would sink because it's a lot more dense. And now, so that the pontoons are so buoyant that when the Big Blue can haul a heavier load without sinking.
okay, so the buoyancy of the Big Blue is how it is able to float on top of the water, because that's what buoyancy is. And it is because in the pontoons it's just air, it's not water, so it is less dense than the water, which makes it able to float on top of the water.
Okay, the fluid pressures on the Big Blue is the water molecules pushing up on it to make it stay afloat on the water.
The hydraulics on the Big Blue consist of just two syringes, the tubes, or the one tube, the string, and the piece that the string pulls when the syringe moves. That back syringe is pulling, it's creating like a suction almost, which is pulling this syringe forward with the water, and it pulls the bucket up. So this is our side view blueprint. So the total length is from this pontoon to the tip of the bucket is 21.5 inches, not including this because this was last minute changes. And the width of it is 13 inches across. Height is 3.5 inches. And the height the length with the boom up is 20.5 inches. The height with the boom up is 11.5 inches. So this right here, up here, is the bucket. This is the pilot's area, like the captain's quarters, and this is just another regular pontoon. Behind this is the deck.
The width of it this way is 21.5 inches, and the width of it this way is 13 inches. And what we have on here is where the driver would sit of the boat in this one, and in these two we will make it like living quarters, so like people would live here. And this is the shovel thing to scoop up the garbage, and the syringes are right here. And here's the deck, and this right here is to when we back it up on a dock, we put that down and push our garbage off of it. Oh, also, these are pontoons as well as living quarters to, keep the boat afloat on the water. And here we have solar panels since our boat is energized from the sun. And this string right here is for when we do our hydraulics, this comes up.
So also the big blue is going to be about the size of a football field approximately, and so it's going to be smaller than most cargo ships, and it also is powered by solar panels or by the sun, as Bailey said. So it'll be a lot more efficient than just cargo ships going along.